Hey guys, here's another video on Riemann sums, this time calculating with Desmos. So I'm going to do the same one as in the last video with the TI-84, but just so I don't have to redo the whole number line thing. But this time we're just going to compute it with Desmos and look at the notation of entering it in there. So just a reminder, we're doing this problem right here. Find L5 and R5, left sum, right sum, 5 subdivisions for this function 2 minus absolute value of x on the interval -2 to 5. And last time we went through drawing out the number line, subdividing it, finding the delta x, all that stuff. So if you haven't seen the other video, do make sure you take a look at that. And then we're going to sum this f of x times delta x. So in Desmos, let's go ahead and take a look at that just to see what you would put in. So I'm going to go ahead and talk to you a little bit about lists first. So if we have, say, let's do L for our list, and I want this to go from -2 all the way to 5, and our step size was 1.4, so we start at -2. The next one was -0.6, and then ... all the way out to 5. So you don't actually have to type in every element. You can if you want, but this little ... will mean just continue. If you don't have this second number, it will just count by ones. So -2, -3, -4, all the way up to 5. But when you put the second number in, that tells you how much to increment each time. So you do have to compute that delta x like we did before. So b minus a over n, and then find how much that's going to be for that first step when you're entering this list. But that gives me a list. If you want to access the list, then you just type in whatever your list name is with these square brackets, and number 1 will be the first element in the list, so that's a -2. L2 will be -0.6, that's the second element in the list. So you just index that list in those square brackets with the name on the outside. So even if I want to put, say, L4, that'll be 2.2, that's the fourth element in that list. All right, so what we want, I'm going to go ahead and put our function in since we're going to need that. So our f of x was 2 minus absolute value, and you can just type, actually I don't think ABS works in this case, but the shift and then that little vertical bar will work for absolute value. So 2 minus absolute value of x is our function, and we are going to sum. So type SUM. As soon as you type the M, it'll change to the summation notation. And we're going to sum which part of this list. So we're going to go from, if we want to left sum, the beginning right there at 1, all the way out to the next to last, so the fifth element in the list. And if we're using 5 subdivisions, that makes sense. We would be adding 5 elements, the left points of all these. So sum n is 1 to 5 of our function. So f of whatever is going to get entered. So in this case, it's going to be L1, L2, L3, all the way out. So I'm going to type in L in on that. So whatever your list is with this index, if it's in, you can use in. If it's I, you can use I. It really doesn't matter what you want there. You can even change it if it makes you feel better to use I. That'll work. So that's just what they call an index. You can use any variable you want in that space. And then don't forget times our delta x, and we're just going to put in 1.4 for that guy. So we get 1.12, same answer we had before for that left sum. And the idea there is mainly just creating that list of numbers that's going to be on the base of our number line. So from -2 all the way out to 5, spaced every 1.4 units. and then entering those list values into that function just like that. If we want to do a right sum, then what changes? So it's still going to be a sum. It's still going to be the same function. We're still going to put in our list elements. So these L of i's, and then times 1.4 for our delta x. But what's going to change? So rather than doing the first element in the list, we actually want to start with the second one and go all the way to the end. So there's a couple ways you can do that. You could still say n is 1 to 5. And I'm going to do, instead of starting with n is 1, I'm going to add lowercase n. I'm just going to add 1 to it. So this would be 2, 3, 4, 5, 6 as I go through the list. It just adds 1 to the first one, so it goes to the next one, next one, next one, all the way down. So you can do it that way, and that gives you this negative 3.08. You could also, if you would rather, change your index and just say, I'm going to start with the second element in the list and go to the last. So from 2 to the sixth one in that list. So second term all the way to the sixth term. So that's another way that you can do it on there. The idea is you're using just the last part of the list rather than the first part of the list. So when we do get that negative 3.08, just like we did before. So that's kind of how you do these left sums or right sums with Desmos. I'm going to go ahead and switch over to the other one. We'll do a midpoint real quick just to see what it looks like, and then we'll call that done. All right, so let's go ahead and try this one right here, number 3, midpoint. And I'll go ahead and just draw out the number line real quick, calculate the delta x, and then we'll switch back over to Desmos. So what we're doing is we're going, say right here, negative 1 to 1. And we're going to do 8 subdivisions. I'm not going to draw 8, but, well, maybe we'll just throw in some. Let's say, hopefully that's 8. And then we'll go ahead and do our delta x. So delta x is going to be this b minus a. So 1 minus negative 1. That's going to be 1 plus 1 or 2. And then the n on the bottom is 8. So we get 2 over 8 or 1/4. So that is our delta x. Again, if you want to use 0.25, that's also fine. The key is I need this number right here. So negative 1 plus 1/4, or we could say negative 0.75 would be the next one. So that's the main thing I'm going to need when I get that list of numbers to be able to get it to step through correctly on those guys. The other thing that you want to do is look at midpoint, right? So midpoint, you want to be a little bit careful. What would be right in the middle of negative 1 and negative 0.75? So I'm looking for what point is right in the middle of that interval. And that is kind of the key part of doing these midpoints is you're starting not at this very left, not at this other kind of subdivision, but right there in the middle. So what we can do is just take an average, say those two. So negative 1, or just add half of this delta x. So half of the delta x would be 1/8. So negative 1 plus 1/8 would be negative 7/8. Or if you want to put that in your calculator, negative 7/8 is negative 0.875. So either way there, negative 0.875. If you like decimals, you can use that, or the fraction negative 7/8. So we'll go ahead and switch back over to Desmos real quick. Our function that we're adding on, this 1 over x squared plus 1. So let's go ahead and switch back over and I'll change a few things. So this is going to be f of x, was that 1 over x squared plus 1, which will look something like that. And our list is going to start at, this time instead of starting at -1, since we're going to do a midpoint, I'm going to change this to, well, it's still L for list, so we'll just keep that. But let's go ahead and start at that -7/8. That's what we said was our first element, and we're ending 1/8 short of 1, so probably should have calculated that out. I think it's just going to be +7/8, but just as a quick reminder, if you were 1/8 short, right, of that 1, which would be right here, that would be a +7/8. So -7/8 right here, +7/8 right here. That's going to be your end. So you do need your end point as well on those. So let's go ahead and go back, and our step size was 1/4. So let me show you a kind of neat trick you can do here. Just say -7/8 plus 1/4, right? That's what it is, even though I didn't calculate it out. And then we're going to end with +7/8. Right. So if you want to calculate this second one, you can, but that's another way you can get around it if you got funky numbers. Now go ahead and see what we're going to do. So this is our f of x. Actually, it doesn't like that list. Let's see. Oh, I got that ... up there in the numerator. Needs to be right there. All right, so now we got our 8-element list, and we're going to do our function value on that list of elements. Our delta x this time is 1/4, and we're going from 1 to first element in the list. This time with midpoint, you're going to add up all 8 of those, right? So we are doing an 8-point thing, so we're going to add up from 1 to 8 on that list, and we don't need that one. So that gives me this 1.5734 for this guy, and you can go ahead and round those if you want, 3 or 4 decimals, definitely 3 if you're doing it in WAMAP, or usually on exams 2 to 3 is fine as well. Sometimes you'll need a little bit more, but I'm going to put 1.5734 for that one. So that was 1.5734. All right, so that's it. So if you want to try number 1 on your own, go ahead. It's a good one you could post to the forums, something like that. But that's kind of left, right, midpoint sums using Desmos, and hopefully that helps you out on the homework. All right, that's it for now.